Hi my dear students. So today I am going to start next topic, inverse trigonometric functions. So this is the first session. Okay. So I am going first basics levels. Okay. So when we say that a function is invertible, a function is invertible. So a function is invertible only if it is bisective function. That means the function is both 1, 1 and onto function. So a function f is invertible if it is both 1, 1 and onto function. So that means 1, 1 function definition. What is the 1, 1 function definition? So different elements of A have different f images in B. Then only f mapping from A to B become 1, 1 function. So different elements have different images. That means no two different elements in the domain of the function have same image. Okay, no two different elements of in the domain have same f image. Okay, next, onto function. Simple definition: codomain is equal to range of the function. Codomain is equal to range of the function. That means every element in codomain has at least one preimage in the domain. So then only the function is onto function. And remember, if your function is a monotonically increasing function or monotonically decreasing and it is continuous function, then it is clearly 1, 1 function. Okay, so every monotonic and continuous function is always 1, 1 function. And if you take its codomain as the range of the function, then it becomes onto also. Hence it is bisective. Okay, so that means every monotonic function, every monotonic and continuous function in its range is always invertible function because it is bisective. Okay, so for example, simple example I am giving. So 1, 2, 3, here alpha, beta, gamma. Suppose 1 maps alpha, 2 maps beta, 3 maps gamma under the mapping function f. So here f maps from A to B is clearly 1, 1 and onto, so hence it is bisective. As it is bisective, its inverse is also a function. That means its inverse is also a function. So look at f inverse, and if f maps from A to B, f inverse maps from B to A. Okay, observe from f inverse B to A, observe it is also a function. And if you observe f inverse is also bisective. That means f inverse is always invertible function. F inverse is always invertible function, and its inverse is f, the function, original function f itself. Okay. Now if you observe, if for invertible functions, domain of the function is same as range of f inverse, and range of the function is same as domain of the f inverse, because as it is invertible, range is same as codomain. Okay, so the domain of f is same as range of f inverse, range of f is same as domain of f inverse. Okay, so now the name of the topic is what? Inverse trigonometric functions. That means when the trigonometric functions are invertible. So what are the trigonometric functions? Sine x, cos x, tan x, cosecant x, secant x, cot x. Okay, all these 6 functions are trigonometric functions. Okay, so generally what is the domain of first function is what? Sine x function. So sine function domain is what? All real numbers. What is the range of sine function? Closed interval -1, 1. Okay, so generally if I define a sine function, if I define sine function from capital R to capital R, then it is neither 1, 1 nor onto. It is not 1, 1 and it is not onto. So hence it is not invertible function. Why it is not 1, 1? Because if you consider sine pi by 6, 1 by 2, sine 5 pi by 6 also 1 by 2. That means many elements have same sine image, same image under the function sine function. So it is not 1, 1. And why it is not onto? Because the codomain is all real numbers, but range of the sine function is what? Closed interval -1, 1. So codomain not equal to range, hence the sine function is not onto. So it is not 1 1 and it is not onto. So therefore sine function from R to R neither 1 1 nor onto, and hence it is not invertible function. Okay. So suppose if I restrict the sine function codomain from capital R to closed interval minus 1 comma 1. If I reduce the size of the codomain from capital R to closed interval minus 1 comma 1, now the codomain of this function, in this case the codomain of sine function is closed interval minus 1 comma 1, which is same as range of the sine function, and hence it is onto function. So in this case the function is onto, but it is not 1 1 function, because the same reason sine 30 1 by 2, sine 150 also 1 by 2. So many elements have same image, so it is not 1 1. In this case still it is not 1 1 function. So in this case still it is not invertible function. Okay. So suppose if I restrict the domain of sine function to closed interval minus pi by 2 comma pi by 2, or closed interval pi by 2 comma 3 pi by 2, or closed interval 3 pi by 2 comma 5 pi by 2, or closed interval 5 pi by 2 comma 7 pi by 2, etc. etc. If you take any one of these intervals, etc., if you take any one of these intervals, the sine function is a 1 1 function, and on its range it is anyway onto function. So if you take any one of these intervals as sine function domain, then in its range the function is both 1 1 and onto, and hence it is bisective, therefore it is invertible function. So sine function is invertible in its range by taking its domain any one of these intervals. But among these intervals, which interval contains numerically least values? Numerically least values. The interval, closed interval minus pi by 2 comma pi by 2. This interval contains, when compared to all other intervals, this interval contains numerically least values. So that's why this interval is called principal interval. Okay. So thus sine function mapping from closed interval minus pi by 2 comma pi by 2 to closed interval minus 1 comma 1 is both 1 1 and onto, hence it is bisective. So sine function mapping from this interval to this interval is both 1 1 and onto, hence it is invertible function. Thus sine inverse is mapping from obviously what? Closed interval. So sine function a to b means sine inverse is b to a only na. So sine inverse is mapping from closed interval minus 1 comma 1 to closed interval minus pi by 2 comma pi by 2. Okay. So sine inverse is mapping from closed interval minus 1 comma 1 to minus pi by 2 comma pi by 2. Suppose if I consider sine function domain is this pi by 2 comma 3 pi by 2, then even pi by 2 comma 3 pi by 2 to closed interval minus 1 comma 1 also sine function is invertible. In that case sine inverse is mapping from where to where? Minus 1 comma 1 to closed interval pi by 2 comma 3 pi by 2. So if you take sine function domain as this, then sine inverse is mapping from here to here. You will get one branch of the sine inverse function. If I take sine function is domain this, then sine inverse mapping from closed interval minus 1 comma 1 to pi by 2 comma 3 pi by 2, you will get another branch of sine inverse. Then by taking this, you will get another branch of sine inverse. Okay. Among all those branches, the branches whose range is closed interval minus pi by 2 comma pi by 2, that branch is called principal value branch. Principal value branch of sine inverse function. Principal value branch of sine inverse function. Okay. So now I am going to draw sine function as well as sine inverse function graphs in these intervals. Okay. So sine function domain, what we have taken? What is the principal interval? minus pi by 2 to plus pi by 2. And sine function range is what? Closed interval minus 1 comma plus 1. Then if you draw the graph, then sine function graph will be like this. So this is the y is equal to sine x function on closed interval minus pi by 2 comma pi by 2. Clearly from the graph also we can say that it is 1 function. If you draw any horizontal line, then that horizontal line meets the graph of the function at most one point. Hence it is 1 function. And also from the graph, what is the range of the function? Closed interval minus 1 comma 1. If you take a codomain also closed interval minus 1 comma 1, then it is onto function. Hence it is invertible function. Okay. Next, the graph of sine inverse. The graph of sine inverse x. So the graph of sine inverse x. Suppose this is the line, say y is equal to x. This is the line y is equal to x. Okay. So the image or the reflection of this sine x, the reflection of y is equal to sine x with respect to the line y is equal to x. You will get y is equal to x is like this. I have drawn wrongly. Okay. So this is the line y is equal to x. So this is the line y is equal to x. Okay, let it be, leave it. This is the line y is equal to x. Okay. So now the reflection of y is equal to sine x. The reflection of y is equal to sine x. Okay. With respect to the mirror y is equal to x gives its inverse, which is y is equal to sine inverse x. So not only for sine x, for any invertible function, the inverse of y, the graph of y is equal to f inverse x. To get the graph of y is equal to f inverse x, first you draw the y is equal to fx graph and take its reflection on the line y is equal to x. So whatever you are getting the graph, that graph is inverse of the given function. So draw the y is equal to fx, draw the y is equal to x, and take the reflection of y is equal to fx with respect to the line y is equal to x. Then whatever you are getting graph, that is the inverse of the given function, that is y is equal to f inverse x. So just now I'm going to draw the same. So y is equal to sine inverse x. So just approximately I have drawn. Okay. So this is the graph of y is equal to sine inverse x. So this is the graph of y is equal to sine inverse x. And if you observe, as y is equal to sine x is the increasing function in its domain, sine inverse x function is also increasing function in its domain. Okay. So this is the graph of y is equal to sine x. This is the graph of y is equal to sine inverse x. Okay. Now, next one is, so remember this point. Which point? Which point we have to remember? The reflection of y is equal to fx with respect to the line y is equal to x, the reflection of y is equal to fx with respect to the line y is equal to x. Whatever you are getting that graph is graph of inverse of the function, that is y is equal to f inverse x. Now domain and ranges. So thus sine inverse x function domain closed interval -1, 1, range is -pi by 2, pi by 2. Similarly, cosine function mapping from 0, pi to -1, 1 is both 1, 1 and R2, hence it is invertible. So thus cos inverse domain is this, range is 0, pi. Similarly, tan function mapping from open interval -pi by 2, pi by 2 to R, it is invertible function, hence tan inverse domain becomes R, range becomes -pi by 2, pi by 2. Similarly, remaining 3 functions. Okay. And here some important points has to remember. So the first important point is when x greater than or equal to 0, when x is positive or x is equal to 0, all these 6 functions are lies in first quadrant. That means all these 6 functions are positive angles. Correct? Anyway, I forgot to give one more thing. So all these 6 functions are what? Angles only. No? So what is the sine inverse x? It is an angle whose sine function is x. Correct? It is an angle whose sine is x. Okay? And cos inverse x is an angle whose cosine is x. And secant inverse x is an angle whose secant function is x. Correct? So all these 6 functions are clearly angles only. No? So now when x greater than or equal to 0, if those functions are defined, then all these 6 angles are acute angles. That means they lies in first quadrant. That means all these 6 angles are positive angles. Positive angles. Okay. And when x greater than or equal to 0, this conversion is holds good. So suppose sine inverse of x by 1. Sine inverse of x can be written as x by 1 also. No? So draw the right angle triangle. So x is the opposite side. Okay, and 1 is the what? Hypotenuse, and adjacent side becomes what? Root over 1 minus x square. Only when x positive, this all conversions are holds good. Okay, so now sine inverse of opposite by hypotenuse is same as cos inverse of adjacent side by hypotenuse. Adjacent side by hypotenuse, and it is equal to what? Tan inverse of opposite by adjacent side. So x by root over 1 minus x square. So similarly, next it is equal to what? Cosecant inverse of hypotenuse by opposite. Secant inverse of, what you will get? Tell me, secant inverse of 1 upon root over 1 minus x square. Hypotenuse by adjacent side. And it is equal to cosecant inverse of, last one, cot inverse of adjacent side by opposite. So these conversions are holds good only when that argument x is positive. For example, sine inverse of 5 by 13 is there. Sine inverse of 5 by 13. That means what is the opposite? 5. What is opposite? 5. Hypotenuse 13. Obviously adjacent side what you will get? 12. Now you tell me, it is converted into cos inverse. So cos inverse of adjacent side by hypotenuse. That is, it is equal to what? 12 by 13. So sine inverse of 5 by 13 is same as cos inverse of 12 by 13. And tell me, it is same as tan inverse of what? Tan inverse of what? 5 by 12, etc. etc. Okay? I hope you understood these conversions. So when x positive, what you have to remember? All these angles are acute angles. Next, if x negative, sine inverse function, tan inverse function, and cosecant inverse function, these 3 functions are negative. That means these 3 angles are negative angles. Okay, and remaining 3, what are the remaining 3? Cos inverse, secant inverse, and cot inverse, they are positive and they are obtuse angles. Obtuse angles. That means they lies in which quadrant? Second quadrant. And these are all negative angles and they lies in which quadrant? Fourth quadrant. So when x positive, all 6 angles are acute and lies in first quadrant. And when x is negative, these 3 functions, sine inverse, tan inverse, cosecant inverse, are negative angles. They lies in fourth quadrant, particularly between minus pi by 2 to 0. And cos inverse, secant inverse, cot inverse 6 are still positive even x negative. And in that case, they are obtuse angle. When x is negative, cos inverse x, secant inverse x, cot inverse x are obtuse angles. That means they lies in second quadrant. That means in inverse trigonometric function, we never used third quadrant angles. We never use third quadrant angles. Okay. Next one more important point. Remember, all these 6 functions are continuous functions. All these 6 functions are continuous functions. That means they are continuous in their domains. Okay. So next to sine inverse x, tan inverse x, and secant inverse x. These 3 functions are increasing functions. These 3 functions are increasing functions, strictly increasing functions. So for example, if I got an inequality in the form of sine inverse x1 greater than sine inverse x2. So on solving, what you will get the solution of this inequality? X1 greater than x2. Because sine inverse function is what kind of function? Increasing function. And whereas triple C, that is cos inverse x, cosecant inverse x, cot inverse x, triple C. These 3 functions are strictly decreasing functions in their domains. Okay, that means whenever we got a situation like this, cos inverse x greater than cos inverse y, then the solution of this inequality becomes x less than y, because cos inverse is a decreasing function. On removing cos inverse function on both sides, greater than symbol changes to less than symbol. That means this inequality becomes reverse. Whereas in case of increasing function, inequality remains same. In case of decreasing functions, inequality changes or it becomes reverse. Next to all these 6 functions are bounded functions. See their ranges if you observe. Okay, by looking their ranges, all these 6 functions are bounded functions. That means they have maximum value as well as minimum values. Okay. But whereas cot inverse x, the minimum value, maximum value does not exist, because your minimum value is the number just more than 0. But it is a finite, but we can't say that particular value. That is why minimum value does not exist. And maximum value also does not exist. What is the maximum value of cot inverse x means? It is just a number before pi. So we can't say that real number. So that's why we conclude what minimum and maximum value does not exist. But by looking at that range, so what you can say, it is a bounded function. Minimum value does not exist, but it is a finite. Maximum value does not exist, but it is a finite, some finite value. Okay. Next to this sine inverse function, tan inverse function, and cosecant inverse function. These 3 functions are odd functions. Okay, odd functions. That is why you will get sine inverse of minus x is minus sine inverse x, tan inverse of minus x is minus tan inverse x. Formulas are there. Cosecant inverse of minus x is what? Minus cosecant inverse x. Whereas remaining 3 functions, cos inverse, cot inverse, secant inverse, they are neither even functions nor odd functions. Okay. So sine inverse, tan inverse, cosecant inverse are odd functions. Hence they are symmetric about origin. Okay. And whereas cos inverse, cot inverse, secant inverse, they are neither even nor odd functions. Because cos inverse of minus x formula is what? Pi minus cos inverse x. Cot inverse of minus x is what? Pi minus cot inverse x. Secant inverse of minus x is also what? Pi minus secant inverse x. So that means cos inverse of minus x neither equal to cos inverse x nor equal to minus cos inverse x. So that is why it is neither even nor odd function. Similarly, cot inverse and secant inverse. So after this next point, next point. So after this minus x properties, so property 1 is what? Minus x property, that is sine inverse of minus x minus sine inverse x, cos inverse of minus x pi minus cos inverse x, and so on. Similarly, cosecant inverse of minus x minus cosecant inverse x. After this property, next property, pi by 2 property. So what are the pi by 2 properties? Sine inverse x plus cos inverse x is what? Pi by 2. Only x belongs to closed interval minus 1 comma 1. And tan inverse x plus cot inverse x is what? Pi by 2. What is the domain? R. Secant inverse x plus cosecant inverse x is equal to what? Pi by 2. What is the domain? R minus open interval minus 1 comma 1. So after that, next to property 1 by x properties. 1 by x properties. So what is the sine inverse of 1 by x? It is equal to cosecant inverse x. So where x belongs to what? R minus open interval minus 1 comma 1. You can write mod x greater than or equal to 1 also, or x belongs to left open right closed minus infinity comma minus 1 union left closed right open 1 comma infinity. Okay, so these two functions are equal only when x takes this. So it is the original domain of cosecant inverse function. That is why sine inverse 1 by x, cosecant inverse x are identical functions, whereas cosecant inverse 1 by x is equal to what? Sine inverse x only when x belongs to closed interval minus 1 comma 1 but x not equal to 0. So only if x takes these values, then these two functions are equal. But this is not a original domain of sine inverse x. Cosecant inverse of 1 by x is equal to sine inverse x only when x belongs to closed interval minus 1 comma 1 and where x not equal to 0. So this is not a original domain of sine inverse x. So cosecant inverse 1 by x, sine inverse x are not identical functions, but they are equal only when x takes these values. Okay, x belongs to closed interval minus 1 comma 1 other than 0. Similarly, cos inverse 1 by x is equal to what you will get? Secant inverse x. So what is x belongs to? Same, x belongs to R minus open interval minus 1 comma 1. So which is the original domain of secant inverse. Hence these two functions are also identical functions. Whereas what is the formula for secant inverse of 1 by x, which is equal to cos inverse x. So where x belongs to same, closed interval minus 1 comma 1 other than 0. So in that, for those values of x only, these two functions are equal. So that's why these two functions are equal in this interval. But it is not a original domain of cos inverse, because here 0 not included. So that's why these two functions are not identical functions. Okay. So these two functions are equal in these values, for these values of x. But these two functions are not identical because of this is not a original domain of cos inverse x. Okay. So similarly, what is a cot inverse x? So it is equal to tan inverse 1 by x when x positive, and cot inverse x is equal to pi plus tan inverse 1 by x when x negative. So this is the important one. Okay, most of the people, they don't know the second formula. So thank you. I'm going to close this first session. In the next session I'm going to start problems. Thank you.